In this video we're going to look at 3 different ways to solve the same question here, the absolute value of x plus 1 equal to x plus 3. So we're going to look at one method with the calculator, one graphical method, and one just doing it by hand. So to start with, the main idea with the graphical method is we split the equation up into 2 sections. So we'll take the right hand side to be y equals x plus 3 and the left hand side to be y equals the absolute value of x plus 1. And after we've done that, we're going to find the intersection point to find the solutions. So how can we graph this? Well, we know that both of these equations are in the form y equals mx plus b, where m is the slope, b is the y-intercept. So reading straight off the right-hand side, we can see that the y-intercept will be 3. So we'll graph that on our plot there. And the slope we can see will be, well, the coefficient of x there is 1. So positive 1 means for every 1 you go across in the x direction, you're going up 1 in the y direction. And that's conveniently on this graph the diagonals of these squares. So it makes it nice and easy for us to graph that line. So we've graphed the right-hand side of the equation. Now to graph the left-hand side, there's a couple of different ways to think about this. I think the easiest one for this question is just to look at the main function here, which is x plus 1. So the y-intercept would be 1, and the slope would be 1. So using the same idea, we can graph the slope here along the diagonals. Or you could just think of it as x plus 3 shifted down to 2 places. So the positive value for an absolute value remains the same, and the negative value will be reflected in the x-axis. Another good method is to look at the breaking point of the function here to make this 0. We can see that the breaking point would be when x is equal to minus 1, and so we can graph our breaking point first, and then graph x plus 1 and check that when we take the negative value of x plus 1, we would then have minus x minus 1, and we can see that this section of the graph is minus x. If we continued it, we would intersect at minus 1 there for our y-intercept. So, all that's left now is to take our intersection point, and we read down for our x value here, we can see that it will be at minus 2. So the solution set for this particular equation, SS for solution set, is going to be, and we're going to assume that we're in real numbers here, minus 2. So how can we do this with the calculator? Well, we're going to graph these functions using this y equals button, and we're going to do the same 2 equations as we had before. We had absolute value, so to draw the absolute value we're going to use the alpha function and f2, the green function here. The first option gives us the absolute value. Then our x button here, minus 1, I think it was. Let me check. Plus 1. So back here, plus 1. And on our next equation, we're going to have x plus 3. Great, and we can see the preview come up already, but to show this on our main screen, we can look at the graph here on the right. And to make it so that it looks exactly the same as yours, let's make it the zoom standard, option number 6. So you can do this at home. And to find what this intersection point is, we don't have to read the graph, we can actually calculate it using this blue calculation function. So we're going to need the second function button, calculate the intersection, which is option number 5. Now the first curve is the absolute value of x plus 1, enter. Second curve is x plus 3, great, enter. Now we want to guess, so we're going to move left or right. You can see my little mouse here needs to go to the left, the cursor. That's about right there, so I'll click enter, and the calculator gives me the same answer. The solution is 2, well, minus 2 I should say. Great, so how can we do this by hand? Well, let's go back here, and we want to say the absolute value of x plus 1 is equal to x plus 3. Well, we have to take the positive situation and the negative situation, so we could just write the positive situation without the absolute values. Now to solve this, well, if we subtract x, we'd get, well, what, 0 equal to minus 2, and so that's never going to happen. There are no values of x where that's going to be true. Or we could take the negative solution, which is minus x plus 1 equal to x plus, well, running out of room, x plus 3, just snuck in, and we have minus x minus 1 equal x plus 3. So solving this here, that we'll take the x terms to the left-hand side, minus 2x, adding 1 will give us 4, and dividing by 2 to solve, we have our solution minus 2. So there are 3 different ways to solve the same problem.